A deep dive into scikit-learn's Gaussian process RBF kernel. The Radial Basis Function RBF kernel, also known as the Gaussian kernel, is a popular choice in Gaussian process GP regression due to its versatility and ability to capture complex relationships in data. Let's dive deep into its workings, key parameters, and applications using scikit-learn's sklearn, Gaussian process, kernels, RBF class. Understanding the RBF kernel. At its core, the RBF kernel calculates the similarity between two data points based on their distance in a feature space. The similarity decreases exponentially as the distance between the points grows, creating a bump centered at each data point. This bump represents the influence of a single data point on its neighbors in the GP model. Mathematical formulation. The RBF kernel is defined by the following formula: kx1, x2, xp, x1, x22 to length scale 2, where x1 and x2 are two data points in the feature space. x1, x2 is the Euclidean distance between the 2 points. Length scale is a hyperparameter controlling the width of the bump or the influence of each data point. A larger length scale results in a smoother function, while a smaller length scale creates a more localized effect. Visualizing the RBF kernel. Imagine a 2D dataset with 2 points, A and B, separated by a certain distance. The RBF kernel creates a bump around each point. The height of the bump at a point C is determined by the distance between C and A or B and A. Length scale parameter. Points closer to A or B will have a higher bump value, indicating stronger similarity. Benefits of the RBF kernel. Flexibility. The RBF kernel can capture complex nonlinear relationships in the data. Smoothness. The exponential function results in smooth predictions, making it suitable for continuous data. Widely used. The RBF kernel is a popular choice for various applications due to its effectiveness and simplicity. Key parameters in sklearn, Gaussian process, kernels, RBF. Let's analyze the essential parameters in the RBF kernel class in scikit-learn. 1. Length scale. Type float or array-like. Default 1.0. Description. This hyperparameter controls the smoothness of the resulting function. A larger length scale creates a smoother curve, while a smaller value leads to a more localized effect. Tuning. The length scale is often tuned using optimization techniques like gradient descent or Bayesian optimization to find the best value that minimizes the error on the training data. 2. Length scale bounds. Type tuple of floats. Default 1e-5, 1a5. Description. This parameter specifies the upper and lower bounds for the length scale parameter. During optimization usage. By defining these bounds, you prevent the length scale from becoming too small or too large, leading to overfitting or underfitting, respectively. 3. Odd. Type bool. Default false. Description. The odd automatic relevance determination flag allows you to set a different length scale for each feature in your data. Benefit. This can be helpful if the features have different scales or importance in the relationship you are trying to model. 4. Constant value. Type float. Default 1.0. Description. This parameter controls the baseline value of the kernel usage. It determines the similarity between points when they are very far apart. Example of using RBF kernel in Gaussian process regressor. Python. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import RBF. Define the kernel with a length scale of 1.0. Kernel RBF length scale 1.0. Create a Gaussian process regressor with the RBF kernel. GPR Gaussian process regressor kernel. Train the model on your data. GPR. Fit-X train. Y-train. Make predictions on new data. YPRED-GPR. Predict-X test. Exploring applications of the RBF kernel. The RBF kernel is employed in various applications, including regression predicting continuous values, e.g., stock prices, temperature, etc. Classification categorizing data into different classes, e.g., spam detection, image recognition. Machine learning building robust and accurate models for complex tasks like object detection and natural language processing. Time series analysis predicting future values based on historical data. Spatial data analysis modeling spatial relationships between points. Key points to remember. The RBF kernel is a powerful and versatile tool for modeling nonlinear relationships in data. Understanding the length scale parameter is crucial for controlling the smoothness and localization of the model. The ART flag can enhance the model's flexibility by allowing different length scales for each feature. The RBF kernel is a widely used choice in Gaussian process regression and beyond. Conclusion. This detailed explanation provides a comprehensive understanding of the RBF kernel, its parameters, and its applications within scikit-learn's Gaussian process framework. Remember, choosing the right kernel for your specific problem involves considering the data characteristics and desired model behavior, experimenting with different kernel parameters and evaluating their performance on your dataset is essential for achieving optimal results.